1, they're asking us to find the zeros of the polynomial, and the zeros will be those x values where the y values are 0. And if you look at problem number 1, I have a difference of squares here. And I know that since I have x squared minus 9, that will factor to be x plus 3 times x minus 3. Because that's a difference of squares. So I factored out the first factor, being a difference of squares. And if I look at this trinomial here, I can also factor this. I know that since it's x squared, I can put an x here and an x here. And the signs are going to be different. The biggest is going to be positive, and it looks to me like I would have a positive 2 and a negative 1. Okay. So this is completely factored. Now, what do we have? Well, I'm going to say it this way. I'm going to claim that I have 1, 2, 3, 4 numbers that are multiplied together. And if I want to set this equal to 0, I can now solve for all of the values of x that will make this function 0. Well, let's see what those would be. If x plus 3 is a factor, then it looks to me like negative 3 would have to be a 0, because negative 3 plus 3 is 0, and that would give me 0 times all of the other factors, which would be 0. If you look at the second factor, you have x minus 3. If x minus 3 is a factor, then it looks to me like x would have to be positive 3. Because 3 minus 3 would give you 0 for that factor, and if you multiply that times the other 3 factors, that would give you a 0 for the function. And if you look at x plus 2, that tells me that negative 2 would have to be a factor, because negative 2 plus 2 is 0. And for the last one, it appears that it would be 1. So this is the answer for problem number 1. On problem number 2, they give us a graph, and sometimes Desmos does not do a good job with sizing, and then this is a particular problem here. But it looks to me like I have 3 zeros, right? I have a 0 here, I have a 0 here, and I have a 0 over here. So I know that 2 of them, just by looking at this small picture, I know that 2 zeros are negative because it's on the left side of the y-axis. So this can't be an answer. This only has 2 zeros. And over here, I've got 2 positive zeros and 1 negative. Well, we've already said that can't be right. So it looks to me like this has to be the only option. Now, luckily for you, when you were doing the bell work, you could actually click on this graph and enlarge it. And I'm not able to do that currently with this slide. So the answers are negative 5, negative 1.5, that would be this one here. And then it looks like positive 2, that would be that 0. And that means that at those x values, the y values are 0, because that's where the graph crosses the x-axis. And finally, let's look at, I just realized I could have enlarged that graph. Let me go back and take a look at that. My apologies. As you can see, it does cross at x is negative 5, x is negative 1.5, and x is positive 2. Learn something new every day. Okay, number 3. On problem number 3, luckily, I have experience, and so do you, right, at factoring, and I can tell that this x squared minus 1 is a difference of squares, so I can factor that to be x plus 1 times x minus 1, and there they are. And then if I factor this trinomial, I can see that the signs have to be the same. They have to be both negative, and the factors of 6 that would give me 5 are going to be 3 and 2. So this takes care of the second part. So this is actually the answer we are looking for. Notice we did not have to find the zeros for this problem. They just said to factor. But what if they had said, find the zeros? Well, once you factor it, finding the zeros is not going to be too difficult, because if x plus 1 is a factor, then negative 1 would have to be a 0. If x minus 1 is a factor, then positive 1 would have to be a 0. If x minus 3 is a factor, then 3 would have to be a 0. And finally, if x minus 2 is a factor, positive 2 would have to be a 0. What does that mean? It means that if x is negative 1, y has to be 0. And I can just keep listing these, right? If x is positive 1, y would be 0. If x is 3, y would be 0. And if x is equal to 2, y is equal to 0. So I could actually write those points out, and I would know the points where the graph crosses the x-axis.